Okay, tuloy natin ating pag-aaral sa thermodynamics for engineers. Ang ating topic ngayon is the first law of thermodynamics. Yung introduction ng first law of thermodynamics is no other than work at saka yung heat. Okay, so welcome and enjoy the study. So yung first law of thermodynamics is commonly called conservation of energy. Conservation of energy, yan ang tawag dyan. Ito yun. So pagka tinanong kayo, ano ba yung first law of thermodynamics? Okay, ang ibig sabihin lang yan, conservation of energy. So in the elementary physics courses, meron tayong study of conservation of energy emphasizes changes in kinetic and potential energy and their relationship to work. Okay? Alam naman natin na inaral nyo na to, mayroong kinetic energy at saka yung potential energy. At ang kanilang relationship sa work. Yung work, diba? Katatapos lang natin ng work. Mayroong work na quasi-equilibrium. Meron namang non-equilibrium at saka other modes of work. Remember that? So, itong sinasabi niya lang, binabalikan niya yung istorya nitong conservation of energy. Okay. So, this more general form of usually called first law of thermodynamics. Alin yung relationship ng work saan sa kinetic energy and potential energy. So other form of energy may be included such as electrostatics, magnetic strain, and surface energy. We will present the first law for a system and then for a controlled volume. So yun yung ating expect dito sa first law of thermodynamics. Okay, let's move on. So yung first law of thermodynamics, i-applied natin to sa cycle. Okay. So, na-discuss na nga natin to, yung concept ng work, concept ng heat, diba, in the previous topic we had. So ngayon, we are now ready to present the first law of thermodynamics. Ito na yun. Recall that the law is not derived or proved from the basic principles. It's not derived from the law or basic principles. Or the law is not derived from or proved from basic principles, but simply a statement that we write based on our observation. And hindi lang yun, kung hindi maraming experiments. So if the experiment shows a law to be violated, either the law must be revised or additional condition must be placed on the applicability of the law. Historically, the first law of thermodynamics, ano again yung first law? Conservation of energy. Yung other meaning. was stated for a cycle. So the net heat transfer i- is equal to the net work done for a system undergoing a cycle. This is expressed in the equation formed by summation of work is equal to the summation of heat. Net ang tawag dyan dito. The net heat transfer, yung Q, is equal to the net. Pagka nag-net ka, nag-sum up ka. Diba? Kaya nga nakuha mo yung net. Kaya yung symbol dito mathematically is summation. Wala namang symbol ng math na net. So, summation. So, pag nagsasum ka, positive, negative yan. So, you are summing it up means you are getting the net. Okay? So, yan yun lang yung ibig niya sabihin dito. So, siyempre, may pangalan yan dito. Equation siya. Equation 4.1. Just for the reference lang yan. Okay? Or pwede mong i-symbol yung integration symbol around the complete cycle. Ay symbol lang siya ito. Complete cycle. Complete cycle. Okay, yun ang ibig sabihin. Parehas lang ang ibig sabihin yan. Okay? So, the complete or the first law can be illustrated by considering the following experiment. Let the weight be attached to a pulley paddle wheel set up such as shown in figure 4-1A. Pupunta tayo doon. Yan. Basahin ko lang itong kasi nag-ano ng derivation ng formula to by explanation lang. Simple explanation but he is deriving the formula. Let the weight fall. Yan, nahulog, di ba? Potential energy yun. Pagka may velocity na at saka may weight, potential nagiging kinetic energy. So, laging magkasama yan, no? Let the weight fall a certain distance, thereby doing work on the system. Contained in an isolated tank shown, equal to the weight multiplied by the distance drop. Ito na yan. Weight times distance. Okay? Or force times distance kapag horizontal work yan. Okay? So, continue. Yan. The temperature of the system fluid in the tank will rise at an amount of delta T. Ito yun. Okay? So, hinulog yan. Paghulog niya, nagkaroon ng work, weight times distance. Thereby, nagkaroon ng delta T sa loob ng alin. The temperature of the system or the fluid in the tank will rise at an amount of delta T. Dito. Okay? So, now the system is returned to its initial state, the completion of the cycle. So, may cycle ka. By transferring heat to the surrounding as implied by a Q or by the Q, ito ang Q mo. dito sa figure B. Figure 4, 4-1, the first law applied to a cycle. This reduces the temperature of the system to its initial temperature. The first law states that this heat transfer will exactly equal to the work which was done by the falling of weight. So, pinoprove niya lang by experiment. Okay? Na pag nagawa ka ng work, pag ito hinulog mo yung weight, ito hinulog niya. No? Pag titingnan mo, imagine mo tumago siya, ito rin yon. Ito bago nahulog, ito nahulog na with this distance. Okay, ito yung distance. So, nagkaroon ng work kasi nga distance, work is equal to weight times D. Okay? Kaso lang magkaparehas ang W. So, sabihin natin na parang maliit ito para may pagkakaiba. O ibahin ko na lang kulay. Yan, maliit siya. Ito yan yung bigat. Yung bigat, nahulog, nagkaroon ng distance. So, work is equal to bigat, yung W times distance. Ito yun. Okay? Ngayon, dahil doon, nagkaroon ng delta T. Kasi work done. Diba? Nagkaroon ng work done dito sa loob nitong container. Okay? So, yeah. Nagkaroon ng delta T. So, sabi natin, pag mayroong delta T, mayroong Q. Lumabas yung Q. Kasi yung heat transfer nga from a system o higher region to a cooler region. Lumabas siya ngayon dyan. So, nagkaroon lang ng cycle. Itong pulley mo, system, naka-attach dyan. Nung hinulog mo, work is done. Ano naging result? Tumaas ang temperatura, nagkaroon ng delta T. Nung nagkaroon ng delta T, nagkaroon naman ng Q. Kasi ang Q is heat transfer. Lumabas siya from the system. So, nagkaroon ng cycle, bumalik lang sa dating estado yung alin? Yung ating pinag-uusapan. Na system. Okay, so yun. I-apply natin ngayon yan sa problem. Solve tayo ng problem. Para makuha natin, maintindihan yung konsepto. Okay, meron tayong medyo magulo, no? Ayan, lagay natin kompleto para naintindihan natin. So, meron tayong figure 4-2. Merong paddle, may pulley at saka may spring. So, sabi rito sa problem, a spring is stretched a distance of 0.8. A distance of 0.8, ayan. and attached to a paddle wheel. Figure 4-2. The paddle wheel then rotates until the spring is unstretched. Calculate the heat transfer necessary to return the system to its initial state. So ang solution mo, work done by spring on the system is given by this. Integral of 0 to 0.8 F times delta T, hindi, delta X. May X ka rito eh. Okay, may X dyan. And that is equal to 100 itong K. Nag-jump siya kagad, no? Actually, yung F mo, binreakdown niya. F is equal to K times X. Okay, ito ay K. K yan. K. K of spring. And then, may X ka. Ito yun. Distance ng spring stretch. Na-stretch siya at saka na-unstretch. It travels or it goes to a distance. Times dx. Yung differential ng x na yun. Okay? So, in-integrate natin. Ito yung integration yan. Shortcut. Naka-shortcut kasi ito. So, integrate mo. Ilabas mo yung 100. That is constant. Labas mo. And then, you will have what? Inside. X dx. Integrate mo from where? From 0 to 0.8. So, galing yung 0. Pag siya ay naka-unstretch, siyempre 0. Pag siya ay naka-stretch, 0.8. So, from, ayan, ganyan yan. Ayan. Okay? So, ano gagawin mo ngayon? Take the derivative. Okay, x dx is equal to x squared divided by 2. Ito ngayon yun. Times 100. Ito 100 mo. Okay? So, ilagay mo ngayon yung, ilagay mo ngayon yung x mo. Kasi from 0 to from 0 to 0.8 yung x. Therefore, plug in the 0.8 x and then 0.x squared divided by 2 times 100 will give you 32 Newton meter or joule yan. Okay? Ngayon, ito yung mahalaga. Sabi niya, since the heat transfer returns to the system to its initial state, a cycle result. So, nagkaroon ng cycle. Kasi bumalik yung state. Bumalik sa initial state. The first law then states that Q2-1 is equal to W1-2. And that is 32 joule, 32 Newton meter. Okay? Okay. So hanggang dyan lang muna tayo. Thanks.